Hello everyone, I'm Jeffrey Ouellette, leader of the Implementation Support Group at buildingSMART International. I'd like to thank you for joining me today as a part of the Open Design Alliance 2020 conference. Last year I had the pleasure of joining you for the first time in Milan to talk about ODA and buildingSMART's new partnership to support software implementations of the IFC data exchange standard. Today I'd like to talk to you about the next evolution, IFC 4.3. IFC 4.3 is the latest version of the Built Environment Data Schema, developed and maintained by buildingSMART International. It is the basis for a new version to replace the current ISO 16739 based on IFC4. Last year I was talking about IFC 4.1, which included the existing building domain aspects, as well as the new foundations for infrastructure with the introduction of linear infrastructure alignment. Soon after that, IFC 4.2 introduced schema extensions for the first of the infrastructure domains, bridges. Earlier this year, work on the railway, road, and ports and waterways domains, as well as the various common infrastructure concepts, was finished, resulting in IFC 4.3, the new candidate standard. With the IFC 4.3 schema, we now have a clear vision in moving toward a standard to describe the entire built environment. To the buildingSMART community, it is a logical step forward, as the domains are highly integrated, as well as sharing elements and attributes that only vary by their context of use. With IFC 4.3, transportation networks, whether accommodating trains, vehicles, or maritime vessels, can be represented alongside service buildings and stations, as well as their geophysical and metropolitan contexts. However, as much as the buildingSMART community has worked on this and continues to plan further schema extensions, it is also recognized that one schema can't do it all, and that IFC doesn't have to be the only standard used. The IFC schema can provide a solid basis and hub for industry digitization workflows and needs, including BIM, GIS, the Internet of Things, lifecycle cost analysis, and design for manufacture and assembly, to name a few. This is so the industry and the greater world can reap the benefits of concepts of digital twins, smart cities, smart grids, and more. While we could devote an entire day to discuss the evolution of IFC and the changes made since 2014, today let's look at a few key examples of how the schema has evolved, expanded, and improved through judicious editing. First off, there's a new fundamental spatial structure concept to accommodate all the different domains. IFC Facility now sits above a variety of these existing and new domain contexts, including buildings, railways, roads, and more. In conjunction with those changes to the spatial context, there was also a new semantic hierarchy for objects with the changing of IFC building elements to a more general IFC built element. After all, why create entirely new classes for beams and bridges and other infrastructure contexts when a beam is a beam is a beam? New elements such as bearing and course, among others, have also been added with the new infrastructure domain developments. And now there are better descriptions of many site-related conditions for all contexts, such as geotechnical concepts, including ways to represent the subsurface strata and means of analyzing the overall geotechnical conditions with models, borings, and derived sections. Lastly, I'd like to point out that over 24 different entities, object types, relationships, and enumeration types have been deprecated. In some cases, they are simplifications that have been considered for some time. In other cases, they have been deemed superfluous due to the other revisions with the new schema. Again, a brief overview, but one that should spark enormous interest in built asset domain experts globally, as the buildingSMART community, represented by industry professionals and owners around the world, take the next steps in making IFC 4.3 the new ISO standard. Last year, we highlighted how the buildingSMART standards and solution process had evolved to incorporate the idea of software first. While the community worked hard on the use case and technical aspects of the schema to satisfy their needs, the new process requires that the schema be proved through implementation in software before being considered a viable ISO standard. The new deployment project for IFC 4.3 was launched earlier this spring, soliciting vendors and other international stakeholders to join the effort. To date, many owners of infrastructure systems in America, Europe, and Asia have committed to moving future design, construction, and management of their road, rail, and maritime networks and assets with BIM-based processes, workflows, and information systems, all leveraging buildingSMART open standards. They've been contributing resources to different stages and work products of the IFC 4.3 development project. I'd like to highlight one significant component of that larger effort. It is a project with financial backing of almost half the transportation departments in the US. This is to create BIM-based standards for the design, delivery, and operation of bridges and related structures, specifying the use of IFC 4.3, as well as using BCF and the buildingSMART Data Dictionary. Today it is bridges, but soon there will be projects for roads and other infrastructure by the American Association of State Highway and Transportation Officials, also known as AASHTO, creating standards which will be used across the entire US. While this is a momentous development for the US, it is also a huge validation of buildingSMART's mission for the digitization of the worldwide built asset industry based on open BIM standards. The new US infrastructure effort is just one of many initiatives around the world which add to the depth and breadth of how buildingSMART's open BIM standards are being adopted and implemented to improve project delivery and outcomes for asset owners and their constituents. Even today, we are seeing buildingSMART community efforts coalesce around tunnels, power and communication utility systems, and landscape architecture. And, as my colleague Leo van Berlo will point out, these future efforts and others will need to be supported with more forward-oriented ideas about the technologies and methodologies that buildingSMART needs to supply to make all of this work. If you haven't already, I hope that your companies see the value in supporting IFC with ODA's platform. And for those of you who have already stepped up and dived in, I hope you continue to see the value that such support brings to your products, your customers, their constituents, and our world. If you have any questions, please feel free to reach out to us at buildingSMART, either through our technical support email address or by registering for and participating in our discourse-based forums. You can also find more information on our main and technical websites. Again, thank you for your time and attention, and I hope you enjoy the rest of your conference.